Our today's question is from application of derivative, maxima and minima. The question is, prove that semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse root 2. So this is a question of cone. So let us draw the diagram first. So this is the cone. This is the cone whose radius is r, height is h, and this slant height is L. We are naming this one as A, this is B, and this is C. This is perpendicular. So given, what is given? Given slant height. So given, let L be the slant height. Be the slant height. So slant height is given. Let R and H be the radius and height of the cone. Now we know in case of a cone, since this is slant height and this is R and this is H, so this is a right angle triangle. So you can apply Pythagoras theorem. So here we get L square. L square will be equals to R square plus H square. So from here we can get L square minus H square is equal to R square. Now it is said that you need to find out the semi-vertical angle, means this one. This is the semi-vertical angle. And let this angle be theta. Let theta be the semi-vertical angle. Semi-vertical angle. Now it is said that this angle will be tan inverse root 2 provided the cone has got maximum volume. Maximum volume. So now what is volume of cone? Volume of cone is equal to V is equal to 1 by 3 pi R square H. So 1 by 3 pi R square. R square is L square minus H square. L square minus H square into H. So pi by 3 here. This is L square into H. L square H minus H into H square. H cube. So this gives me V. Now differentiating V with respect to H. If I differentiate, so what I'll get? I'll get dV by dH. So dV by dH, pi by 3 constant. So differentiation of this, L square H will become L square, H cube will become minus 3H square. This is my dV by dH. If I do double differentiation of this, then that will suggest me whether it is maxima or minima. That I will. So let us do that first. So d square by V dH square. If I do the second order derivative, so this will remain pi by 3. L square, this will give me 0, and 3H square will become minus 6H. So this will be minus 3 and this 6 will cancel, minus 2 pi H, which is less than 0. So if the second order derivative is less than 0, then it is maximum. So then it is maximum. So we have proved that the volume maximum, it has been proved. Now we need to find out at which point, where, that is the critical point, at where, with, for what value it will, the volume has become maximum. So for that reason, what we do, we have to do dV by dH, we have to prove equal to 0. So what is my dV by dH? dV by dH is this, pi by 3 into L square minus 3H square equals to 0. So 3 goes that side, it is, that particular part will be 0, so I can get this entire part will be 0, so L square will be equals to 3H square. L square is equal to 3H square. Now what is L square? L square I know, R square plus H square. So R square plus H square is equal to 3H square. So from here, H square is taken that side. So you get R square is equal to 2H square. So if I do square root on both sides, so we get R is equal to R is equal to root 2 into H. R is equal to root 2 into H. So we get R by H is equal to root 2. R by H is equal to root 2. Now if we come to triangle ABC, in right triangle ABC, so what we have learned that for R by H is equal to root 2, the volume of the cone will be maximum. Now in this right angle triangle, since this theta is the angle, so for this theta, tan theta will be what? Tan theta will be perpendicular by base, so perpendicular will be R and base will be H. So tan of theta will be equals to R by H. Now this R by H value I know root 2. R by H is root 2, therefore theta will be equals to tan inverse root 2, which I needed to prove. The tan inverse root 2. Hope you have followed the way I have done this particular sum. I'll give you a similar question for you to try.